Here we have question 1, mixed exercises. Okay, and don't let this physicsy notation affect you. Okay, if you don't take physics, that's fine. You can still do this question. It just takes off your kind of GCSE knowledge. But even then, even if you didn't know Newton's, well, didn't know Force, you can still get the right answer here. Okay, so calculate the magnitude of R in newtons. All right. So what is R? R is F1 plus F2. So let's figure that out first. Okay, and whenever you do this addition, I really strongly recommend you writing F1 and F2 in terms of our column vector. Okay, I find it much easier. I don't know about you, but my I's and my J's, as I do lots and lots of workings out, I often get confused by them, and I find this way simpler to understand. Okay, so we're doing minus 3, 7 plus 1 and negative 1. Okay, and here we're just doing negative 3 plus 1 and then 7 take away 1. Okay, so R is negative 2 and 6. So the magnitude of R, what does the magnitude of R mean? Well, here's R, okay, and here is your vector. Okay, it's going across 2, back 2, kind of up by 6. Okay, and we're using Pascal's triangle to, not Pascal's, Pythagoras theorem, sorry, I said that, Pythagoras theorem to figure out what this R is. Okay, so the magnitude of R, kind of the length of R, is by Pythagoras 6 squared plus, as in you can say negative 2 here, but I thought you just do 2 squared. Okay, so this is square root 36 plus 4, which is square root 40. Okay, and then here you're finding a square root number. I'm sure you all know how to do this bit of it, and you get 2 root 10, and then your units here are newtons. Okay, perfect. That's question A. Next, calculate to the nearest degree the angle between the line of action of R and the vector J. Okay, lots of strange wording here. Line of action of R. Okay, what does all of this mean? Well, let's put B. Okay, line of action of R and the vector J. So we know what the vector J is. Okay, so let's put the vector J. And the line of action of R, it would make sense that this is R, right? Okay, and the angle between these. All right, even if you're not 100% sure what the line of action is, this is a very, very good place to start. Okay, finding the angle between these two vectors. Okay, now what more specifically is this angle? Well, we've got 2 here, 6 here. Okay, which means we have 2 here, 6 here. Okay, and now we are just using sine, cos, and tan. Okay, so we got the opposite and the adjacent, so we use tan. So tan of this angle is a third, then inverse, tan inverse of a third. Okay, which gives our x to be 18 degrees. Here we have question 2, and one of those questions where when you're revising it throws you off straight away because there's just so much information. Too much information for a math student. Okay, but we'll break this down. Okay, so you've got a small boat S drifting in C, models a particle moving in a straight line with a constant speed. Okay, fine. When first sighted at 9, S is a point with position vector that relative to the fixed origin. Okay, so let's represent where it is at the moment at 9. Okay, so back 2, down 4. This is S at 9. Okay, now where's it at 9:40? Well, it goes across 4 and down 6. Okay, so relative to the origin, here is where it is at 9:40. That's where S is at 9:40. Okay, calculate the bearing on which S is drifting. Okay, so this is, do we remember bearings from GCSEs? Okay, well, key thing about bearings is you need to do a north from where it's from. Okay, so it's drifting from 9 to 9:40. Okay, it's got to start at the earliest time, so that's how we know it's from here. Now, bearings is this clockwise angle. Okay, what is this angle? Okay, well, we can figure out this angle by using SOHCAHTOA. Okay, but then we don't know if we can figure out this angle yet. Okay, So instead, what we're going to do is we're going to draw a horizontal line here. Okay, so it's because we know this angle is greater than 90 degrees. We make this 90, then we've only got to figure out one angle. Okay, and this one angle is inside this triangle. Okay, and this triangle we do know the dimensions of. Okay, because it's across by 6, and 6 take away 4 is 2. Okay, so we know the dimensions of this triangle, so we can then calculate this angle. Let's call that x. Okay, so using SOHCAHTOA, we've got opposite and our adjacent, so then we've got x being the tan inverse of 2/6, so x is 18 degrees. Okay, but we didn't want x as 18 degrees. Well, we did want x at 18 degrees, sorry, but they weren't asking what x is, they were asking for the bearing. Okay, so therefore, that's what the 3 dots mean. Therefore, the bearing is our 90 degrees plus our 18 degrees, this full angle here. Okay, that's 108 degrees. Next, we need speed. Okay, and whenever you're asked for speed, this formula should just jump out to you. Okay, it should be instinct at this point. Okay, speed is distance over time. Okay, we know our time. Okay, so let's write that down straight away. We know our time. Okay, and let's do this in hours. So 40 out of 60 hours. Okay, so 2/3 hours. All right. Now distance. Distance is the harder one to calculate. Okay. Distance is going to be this drift. Okay. This vector drift is what we want to find the distance of, because that's the speed that S is traveling. Okay. And we can find this using our 2 initial vectors. Okay. But that diagram is quite confusing. So let me rewrite what we had. Okay. So we had -2, -4 from the origin. And then we had 4, -6 from this origin here. Going this way, going this way. And then our drift here, we'll label D, is kind of the path that S is taking as it drifts. Okay, so what is D? What is this D? Okay, well, it's -2, -4. All right, because we're going against the flow in the opposite direction. And then we're adding 4, -6. Okay, so we got 2 plus 4, 6. 4 take away 6. Okay, so this is our vector for our drift, but we want to find the distance that it drifts. Okay, so we have, using Pythagoras' theorem, we get, this is root 40. This is skipped a few steps there. Root 40, 4 times 10, 2 root 10. Okay, so going back to our speed is distance over time. We know our distance, which is 2 root 10. Okay, what is our units we're using here? Well, we've got kilometers. Okay, so this is 2 root 10 kilometers. Okay, so 2 root 10 over 2/3. Okay, that was our time. This is 3 root 10 kilometers per hour. Okay, and as this is physics, okay, we don't want to leave it as a surd. Instead, I'm going to put that in my calculator, and I'm going to get 9.49 kilometers per hour. And that is your final answer. Here we have question 3, and as you can start to see, vectors, they love involving physics-y questions. Okay, so we got the motion of a ball that's kicked by a soccer player. Okay, it's modeled as a particle traveling with constant velocity here. Okay, find the speed of the ball. Okay, we know that speed is the magnitude of your velocity. Okay, so another way of saying this is just find the magnitude of this vector, which we've done many times, hopefully. Okay, so speed is going to equal the square root of 16 plus 80. Okay, so square root of 97. Okay, and we can put that into our calculator, and we have that as 9.85. Okay, and this is the same units, so it's going to be meters per second. All right, now we need to find the distance of the ball moves from A after 6 seconds. Okay, so initially it would have moved nowhere, right? And then after 6 seconds, it would have done 6 times what it moves in per second, if that makes sense. Okay, so then we do our answer from before times 6. So then we get 59.1 meters. Okay, hopefully that should make sense. Comment on the validity of this model for large values of t. Okay, so when t is really, really big, all right, then the distance is going to be really, really big. All right, so that is unreasonable. Okay, if you've ever kicked a soccer ball in your life, sorry, football, I don't know why I said soccer ball there, football, all right, you should know that eventually it's going to stop. Okay, but this, as it's been modeled as constant velocity, is never going to stop. Okay, so a comment that says something like that, it's not valid, as it should be decelerating, and the constant velocity is only valid for kind of small t or the initial t. Okay, here we have question 4. All right, so we have a trapezium with AB parallel to DC. So let's draw out our trapezium. There we go. So AB is parallel, DC is 4 times AB, so let's make this top one AB, so A to B, and then it's parallel to this one, which is going to be a D to C. M divide D to C, so that's a DM to MC is 3 to 2, so sorry, 3 to 2, so DM is just a bit bigger than MC. So A to B is A. Okay, so if A to B is A, then D to C is 4 lots of A to B, so 4A. Okay, B to C is B, and that's all the information we've given. Again, we can find D to M and we can find D to C by breaking this up. So D to M is going to be 3/5 of 4A. So D to M is going to be 3/5 of 4A. And then M to C is going to be the remaining 2/5 of 4A. Okay, so 8A over 5 and 12A. So first we want A to M. Okay, A to M. All right, so A, let's always draw it on our diagram, A to M. And we can't go this way because we don't know what A to D is yet. Okay, so we're going to have to go the long way. We start at A, so we're going to have plus A plus B. Now, we know M to C, but we need C to M, so then we're going to take away 8A over 5, and that ends us where we need to end. Okay, so now we simplify. Okay, so we have B minus 3A. It's part B now. We want B to D. Okay, so we want here. And yet again, we're going to go, we can't go that way. So we're going to have to go this way. B to D, so we've got plus B and then minus 4A. Perfect. Okay, then our next one, M to B. Let's go this way, starting at M. So we've got MC minus B. So MC, yep, minus B. Perfect. And then last one, we have D to A. Okay, so that one that we kind of needed, or we didn't need as we did it other way, but it's quite helpful to have. So D to A, we're going to do 4A, take away B, take away A. 4A, take away B, take away A. Now, throughout this, you can see I'm not doing, for this case, okay, I'm in school, I'm sure you've broken down the steps. You'd kind of say, okay, so we need to do DC plus C. So you'd say DC plus CB plus BA, and that's the same as D to A. Okay, you need to get used to doing these steps without writing this explicitly. But if you're making lots of mistakes, then definitely do this first. Okay, break it down. Not making mistakes is always the first thing you should worry about. Okay, that is question 4. Here we have question 5, and yet again we're thinking about parallel lines. Okay, so if they're parallel, we need to share this scale factor. Okay, so let's write these two vectors. We've got 5k, and then we've got 8, 2. Okay, and for them to be parallel, this is when we can say equals with this scale factor. Okay, so 5 equals 8 lambda. This means that lambda must equal 5/8. Now we can use this to find k. So k must be 5/4, which is 1.25. And that's your final answer. K is 1.25. Okay, here's question 6, and we're adding column vectors. Okay, and the key thing of adding column vectors, the actual maths is not difficult, but it's managing these negative numbers that can get caught up, and you can easily make mistakes. Okay, so we've got 17 take away 5 is 12, 2 take away 3, -1. Part B, we've got A take away 2b, so 7/4, take away 2 lots of b, which is 10 -2, and then we're just adding c. Okay, and as you can see already, these negatives, if we're not careful with them, can start getting confusing. Okay, so this is -18, so we've got 7 take away 20, -13, take away 5, -18, +4, 8 take away 3, -18, +5. Okay, next part C, 2a plus 2b, so 2 lots of a plus 2 lots of b, take away 3 lots of c. Okay, and as you can see, you need to be careful of this negative. So I'm going to expand them all first, just do this extra step, just to make sure we get this all correct. And now I'm going to add them all together. Okay, so 14 plus 15 first, 29, 49, 4 plus 9, 13, and that is our final answer. Here we have question 7, a good question. Okay, so A to B is 3, 5. Oh, now it depends what you mean by a good question, but it's exam style questions, so something that is definitely worth knowing. Okay, so B to C. We want B to C. We've done this many times. Okay, we need to go against the grain here, and then we're going to go with the grain there. So we're going to have B to C is going to equal -3, 5 plus 6 and 3, which is going to equal 3, -2. Okay, and if the question gives you it in I and J, then it's always good to convert back to I and J. But when adding and subtracting, definitely use column vectors, because my I's and my J's, I always get mixed up by them. So yeah, that's what I'd recommend. Okay, part B now, we need to find the angle BAC. Okay, this angle BAC here. Okay, and hopefully what comes to mind straight away is your cos rule. Okay, so b squared plus c squared minus a squared over 2bc. Okay, what is a? Well, we have this as big A, and little a has got to be opposite big A, and then this being b and that being c, doesn't matter. Okay, now we've got vectors for these a to c and b to a. Okay, but we don't have its magnitude, so we need to figure out the magnitude of all these sides. I'm going to draw a little new triangle for that. Okay, so we've got square root of 6 squared plus 3 squared. We've got the square root of 3 squared plus 5 squared. And we've got the square root of 3 squared plus 2 squared. Okay, so that means that our triangle has got, this length will be 9 plus 4, square root 13. This will be 36 plus 9, which is 45. This will be 9 plus 25, which is 34. Okay, so we've got all our magnitude of our side lengths. We can sub this in to our calculator. Okay, obviously b squared will just be 34, so we don't need to put square root then. Square it, take away 13 over 2 times square root 34 times 45. Okay, we're going to get 0.84366, blah, blah, blah. Just use that as answer in your calculator, cos inverse, and then we're going to get 32.5. degrees. Okay, and that is the angle that we needed. Now, part C, we want to find area. Okay, another formula, that's why it's such a good question. Make sure you know your formulas. Half AV sine C. Okay, half AV sine C. Okay, but that is the exact same as saying half BC sine A. You're just turning around the labeling. Okay, we know what B and C is. It's 45 and 34. 45, 34. Okay, and then we use sine A, we just use answer in our calculator. And when we sub that in, we should get square root of 35 times 34 times sine answer, and we get 10.5. Exactly. Okay, that's when you know the answer's right, when you put in all those different weird numbers, square root 45, square root 34, and you get such a simple answer like 10.5. Here we have question 8, and we need to find the resultant vector, which is parallel. Okay, parallel means they share a scale factor, and we need to use this to find the value of p. Okay, so this is a visual topic, so it's always good to draw out the diagram. So this will be A, and B will be positive in the I and a negative P. So going something like that. Okay, so our resultant vector here is say that R will take the shortest route possible. Okay, so R is just going to be these two added together, 2p, negative p. Make sure to have this negative p there. So 4 plus 2p minus 3 take away p. Okay, so this is our resultant vector, but this resultant vector is parallel to C. Okay, and just a little sanity check. 2, negative 3 would be going in this direction, so that is perfect. Okay, so we make these equal to each other. So 2, negative 3 is going to be a multiple of our resultant vector. Okay, now we've got simultaneous equations. We've got two unknowns, our lambda and our p, and we need to solve for p. Here are our two equations. Okay, rearrange in terms of lambda, so 2 over 4 plus 2p equals lambda, and lambda also then equals from the second equation this. Okay, we simplified both fractions, so 1, 2 plus p equals times by -1 top and bottom. Okay, so 3 plus p equals 6 plus 3p. So -3 equals 2p, so we get p equals -3 over 2, so -1.5. Okay, we don't need to find what lambda is. They don't ask for lambda, we just need the value of p. Now, we need to find the resultant of vectors a and b, so this is just finding out what r equals. Let's use r up here. So we sub in p is -1.5, and we get 4 take away 3, so +1, minus 3 take away 1.5, so we get -1.5. Okay, so it's always good to write the answer as they give it. So they give it in terms of I and j, so we give our resultant vector in terms of I and j, and that's our final answer. Here we have question 9, and the key bit of information we need is this unit vector. Okay, so firstly, what is a unit vector? Well, if we look at A as a vector, okay, it's across 8 in the I direction and up 15 in the j direction. Okay, so we know that its magnitude is going to be this. Okay, which is 17. All right, well, for it to be a unit vector, we only want the magnitude to be 1. Okay, so magnitude of unit vector is 1. Okay, so at the moment this has a magnitude of 17, we need it to be 1. Okay, so what we do is we divide this vector by 17. Okay, and that will force its magnitude to be 1. Okay, so this unit vector is going to be 1 over 17, lots of 8i plus 15j. Okay, that forces, when we find the magnitude of this, it's going to force it to have a magnitude of 1. Okay, so that's part I. Okay, I went into a lot of depth there, so then the rest of them are more simple. part I, we need to find the angle the vector makes with I. Okay, so we've already got this diagram here, but we'll draw it again. Yeah, and we need to find the angle that the vector makes with I. Okay, so here's positive I. Okay, we need to find this angle. Okay, well, we're going across 8 and up 15, so using SOHCAHTOA, we need the tan of this angle, so F is opposite over adjacent. So then our x, if we put this in our calculator, tan inverse of 15 over 8, and that gives us 61.9 degrees above I. Okay, because we could also have 61.9 degrees below I. Okay, so we need to specify if it's above or below. Perfect. Now, part B, we've got 21i minus 7j. 21i minus 7j. Okay. Now, first, we need to find the unit vector. Okay, it's going in the same direction. All right, and now we know we just need to find the magnitude of b, okay, which is the square root of 24 squared plus 7 squared. Okay, put that in the calculator because I can't do that in my head. And we get 25. Okay, so then to find this unit vector, we just divide by 25. Perfect. Okay, now time to do our sketch. Okay, so it's 24 in the I direction, but it's down 7 here. Again, we need to remember that I is going this way. Okay, so we need to find this angle here, SOHCAHTOA again. So tan x, this x, is your opposite over your adjacent. Okay, so x is tan inverse of 7 over 24, which is 16.3 degrees. Okay, and now we specify that it's below I. Perfect. Okay, C, minus 9i plus 40j. Minus 9i plus 40j. Okay, this is our C. Okay, yet again, we find the magnitude of C, which is 41. So the unit vector is going to be 1 over 41, lots of negative 9 plus 40j. Perfect. Okay, next we need to find the angle that it makes. Okay, so here's our origin. Here is I. Okay, but it's going back 9 and it's going up 40. Okay, so we want to find the angle it makes with I, so we want to find this angle. Okay, so if we can see this triangle, we find this angle x, which is easier, then we can do 180, take away that. Okay, so tan of x is opposite over adjacent, so x is tan inverse of 40 divided by 9, which gives us 77.3 degrees. Okay, but we want the angle it makes with I, so we're going to do angle with I equals 180. Take away that, which is 103 degrees. And yet again, we label it above. Okay, because you could have 103 degrees going below. Now, part D, figure out what our D vector is. We have 3i minus 2j. 3i minus 2j. Okay, yet again, we need to find the magnitude of D, which is going to be the square root of 9 plus 4, which is square root of 13. Okay, so then our unit vector is 1 over root 13, 3i minus 2j. That's our unit vector. Okay, now the angle this makes, we're going 3 in the positive direction, 2 in the negative. Okay, so we want to find this angle because this direction is I. We want to find x. Tan x is opposite over adjacent. So then x is tan inverse of 2/3, which is 33.7 degrees, and we've got to specify below. Okay, and that's your answer for question 9. Okay, here's question 10. Okay, and one of those questions where it feels like you don't have enough information, but you do. Okay, so we're told that the magnitude of A is 15. Okay, so this right away, I'm not even reading the rest of it. Okay, I'm going to represent what this means to us. Okay, so if we were to find the magnitude of this and they were actual numbers, okay, what we would do is the magnitude of A is the square root of p squared plus q squared. Okay, and we know this is 15. Okay, so the square root of p squared plus q squared must equal 15. Okay, and that's our first fact. Next, we're told that it makes an angle of 55 degrees with I, so we need to find the value of P and Q. Well, let's draw a diagram. This topic is visual, so we go I, and it's making an angle of 55 degrees with I, okay? And why I paused there is I was unsure if I was to draw this arrow up or down, okay? I didn't know from the current information I'd read, but I looked back and P and Q are both positive constants. So that tells us that this arrow has to be going in this direction and making an angle of 55 degrees here, okay? So what have we got here? Well, P and Q. Okay, using SOHCAHTOA, we've got opposite and our adjacent. So tan 55 equals opposite over adjacent. Okay, let's put in our calculator. What is tan 55? It's 1.43. Okay, this then means that Q is 1.43 lots of P. Okay, we can then use this to sub in to what we had before. Okay, so let me bring down what we had before. We had before that P squared plus Q squared, square root of that equals 15. Okay, now let's solve for P. Okay, so we're going to sub in what we have as Q. Okay, and we're going to get rid of this square root, so P squared plus 1.43P squared equals 225. Okay, now we're going to square 1.43. 1.43 squared is 2.0449, so we're just going to say 2. So that leaves us with 3p squared equals 225. And then we're going to 225 divided by 3. Answer square rooted is going to leave us with p equals 8.7. Okay, 8.66, 8.7. Okay, there's some rounding errors here, but this is the exact method. So then we sub in P is 8. Well, what I got on my calculator, times that by 1.43. Okay, and that gives us that Q is 12. Okay, we're doing two significant figures here because there's quite a lot of rounding. Here we have question 11. And we're told the magnitude of this vector with a kind of unknown k here. We need to find the value of k. Okay, so how we find magnitude is we would do 3 squared plus k squared, square rooted. Okay, I know technically there's a minus k here, but it all cancels out when we square it. That equals 3 root 5. Okay, now square both sides. 3 squared plus k squared equals 9 times 5, which is 45. Okay, so we get k squared plus 9 equals 45. So k squared equals 36. So k equals plus minus 6. Okay, do we know anything about k? No, we don't know if k is positive or negative, so we say k is plus or negative 6. Here we have a question so hard that Edexcel has, since 2020, had to remove this. Okay, so this is a question pre-2020. If you see it in your textbook, still very, very difficult question. Okay, so let's go through it. Express vector on in terms of a and b. Okay, so you want to express this on in terms of a and b. What is a? O to a is a, and O to b is b. And this point m divides OA in the ratio 3 to 2. Okay, MN is parallel to OB. Perfect. So it's going to be some multiple of B because they're parallel. Express ON in terms of A and B. Okay, perfect. So let's look at A. ON in terms of A and B. Well, you'd get ON equals 3/5 A plus lambda lots of B. Okay, but this question doesn't say in terms of A, B, and lambda. It's just in terms of A and B. Okay, so how do we figure out what this lambda actually is? Okay, and the way we do that is we need to think of this shape as similar. Okay, these and these are two similar shapes. Okay, or another way of thinking about it is we're going to take this different route. Okay, so what happens when we take that route? Okay, this is still going to be on. All right, so let's represent this different route in blue. We're still doing O to n. Okay, but we're going to go through the whole of A, and then we're going to go down this an. Okay, now what is an? Okay, so for now we're just gonna, I know it leads to more and more that we need. For now, I'm just gonna leave that as an. Okay, think of the whole triangle now. Okay, 0, A. Okay, and we take away the noise. All right, we know what A to B is. Okay, A to B is B minus A. So A to B is B minus A. Okay, this A to n is then some fraction of A to n. A to B, sorry. Okay, we represent this t. It's just some fraction of A to B. Okay, so now let's sub that into here, back into our blue. So O to n could also be represented as this fraction of A to n. Okay, so we've got two equations now, our black and our blue, that represents O to n. Okay, so let's equate these two together. So 3/5 A plus lambda B has got to equal, let's put this back in blue, A minus T lots of A plus T lots of B. So another way of saying this is 1 minus T of A plus TB. Okay, now those that have seen the solutions on Physics and Maths Tutor would start to see some similarities here. Okay, but instead Physics and Maths Tutor plucked this formula out of nowhere. Okay, and they equated it to this previous formula that was probably the easier of the two to spot. Okay, why have they just set this lambda? Okay, I've used t. Okay, why can they just set it to be lambda? Well, when we can compare coefficients between our blue and our black formula, okay, the coefficient, the number in front of this b, must be the same. Okay, so this gives us that lambda must equal t. Okay, so that then gives us our formula, 1 minus lambda lots of A plus lambda B. Okay, and now we can solve for lambda is 2/5. Okay, so what did we actually want? What did the question actually ask for? Express vector on in terms of A and B. We're really nearly there. We just now have found what lambda is, so we can say that O to n is 3/5 A plus 2/5 B. Okay, and that is O to n. Nice. Now let's look at part B. Find vector m to n. Okay, well, we've kind of already done that in part A. Okay, we found lambda, so then we can say that, sorry, I forgot what that vector was called. M to n is 2/5. M to n is 2/5 b. It may be part why they've removed that question, because we've kind of already solved that in above. And now C, we need to show that AN to NB is 2 to 3. Okay, AN to NB is 2 to 3. Okay, well, we knew what AB was. Okay, AB was B minus A. Okay, and then we know this T we've now figured out is 2/5. Okay, so A to N, we know that A to N is 2/5. Very clear. 2/5 of A to B. Okay, let's not slack on our notation. All right. A to N is 2/5 A to B. Okay, so A to B. If this is 2/5 to the N, okay, this means it must be split in a 2 to 3 ratio. Okay, and that is the answer to question 12 pre-2020 textbook. Here we have question 13, and we're asked to find the angle between R and I. Okay, but the problem is with R is we've currently got two unknowns. Okay, so we can't figure out what the angle is between R specifically and I. But what we can figure out is the angle between this parallel vector and I. Okay, because these are going to be the exact same thing. So let's draw out this parallel vector, 3, -1, and let's draw out what I would be. Okay, so R is parallel to this vector here. Okay, so even if R was, I don't know, like this, then you still have the same angle, because this is going to then be your I. Okay, so the point being here is that the parallel vector to R is going to have the same angle between I as R does. Okay, so what angle is this between I and 3, -1? Well, we draw out our triangle, then we use SOHCAHTOA. Okay, we've got the opposite and the adjacent. So we've got the tan inverse of a third, which is 18.4 degrees. Okay, we're going to specify that this is below I. Perfect. Now part B. Show that P plus 3Q is 11. All right, so how can we create this formula? Okay, you've got to first start at what is something that I can solve. Okay, and I'm sure some of you might have tried to solve R equals F1 plus F2, kind of equated it to this parallel using a scale factor, and then got to that point and thought, oh no, I can't find this angle anymore. Okay, but use that from part A. And if you didn't do that and you spotted this A first, perfect. Okay, but in this part 2, we're using the standard method that we find the angle between R and I. Kind of part A has kind of helped us along that way. Okay, so what is R? Okay, at one point we should figure this out. At one point this should be useful, even just picking up exam marks. So 4 plus P, and then Q take away 5. So this is R, and this is parallel. So 4 plus P, 5 take away 5 is parallel to R3 -1. Okay, so we have the scale factor of lambda. Okay, now we need to cancel out lambda, and I'd bet a lot of money that this is then going to come out at this. Okay, so let's try that out. 4 plus P equals 3 lambda. That's the top equation. And then Q take away 5 equals negative lambda. That's the bottom equation. Okay, let's make these times by -3 on both sides. Okay, now we can make these equal each other. So 4 plus P equals -3Q plus 15. Okay, and as you can see, we're getting to the form that we want. P plus 3Q equals 11, which is exactly what we wanted. Okay, and this is problem solving, that not knowing how you'd choose to do that step, which is the hard bit. The actual algebra behind this is not difficult, okay, but it's trusting that this is how we can create a formula in terms of F, P, and Q. Okay, knowing we've got enough information with this resultant vector being parallel to this vector that can give us an equation in terms of P and Q. Okay, now given that P is 2, find the magnitude of R. Okay, so P is 2, which means that 3Q equals 9, so Q equals 3. Okay, what was our resultant vector? Our resultant vector was 4 plus P, Q take away 5. Well, we've got P, which is, so now 4 plus 2 is 6. Then we got Q, -2. So this is going to be the square root of 36 plus 4. And in this chapter, if you get 2 root 10, well, about 3 out of the 14 have been that. So I think you'd be correct. We have the initial speed and the final velocity. Okay, initial velocity, final velocity. I will also find the acceleration, so let's plug that into the formula. So we do V take away U. Okay, and I think it's always good to leave these in column as column vectors. Okay, because those are the easiest to work with. Okay, so this is a half times this, so -3, 5, 6. That. Find the magnitude of acceleration. Okay, that is then just the magnitude of this column vector A So that's the square root of 6 squared plus 3.5 squared. Okay, and I can't sadly do that in my head, so I'm going to put that in my calculator. And we come out at 6.95, and then what are our units? Meters per second. So our acceleration, meters per second squared. Okay, here we have the final exercise of this chapter, and quite a difficult challenge. Okay, so with something like this where you can't initially see the endpoint, always start off by drawing what you can. Okay, vectors are very visual. Draw a diagram, you might get some marks for it. Also might help you get to the final answer. Okay, so let's start off with this straight line. Let's rewrite this as y equals 5 minus 5/3 x. Okay, now I'm going to set x to 0 when x is 0, then y is 5. Okay, so this is one of our points. Then our other point is when y is 0, we're going to have x. So let's explicitly say that. Okay, x is going to be 3, right? Because if you sub in this to be 3, you get 5, take away 5. Okay, so x is going to be 3. And then this checks with our negative gradient that we need. Okay, so this straight line is y equals 5 minus 5/3 x. Okay, now, given that the magnitude of O to B, okay, B is some point on this line. All right, the magnitude of O to B, I think it's always helpful to figure out what this is as an actual number. Okay, so I'm going to put that in my calculator. Square root of 34 over 2. Okay, and it's going to be 2.915. Okay, so we have an estimate of how kind of big this is going to be. So this point B, okay, or the two possible point B's, going to have to be inside this triangle here, okay, on the line inside here, okay, because anything outside is going to be bigger than 2.9 as a distance. Okay, so let's label this our origin. These are our two possible point B's. Okay, so we define possible expressions for OB, two possible expressions, okay, in the form of R, I's, and J's. Okay, so we've got O to B. Let's draw out that vector, O to B, O to B. Okay, and we know that length is square root of 34 over 2, square root of 34 over 2. Okay, now what you can see here is I've drawn two triangles. Okay, this B coordinate is kind of our x1, y1, B coordinate is going to be x2, y2. And this length is going to be, see, x1 here, x2 there, y2 there, y1 there. All right, so hopefully you're looking at that and you're thinking Pythagoras theorem. Okay, so our x squared plus our y squared for our b coordinate is going to equal our c squared. Okay, c squared in this case is square root of 34 over 2 squared, so 34 over 4, which is 17 over 2. Okay, so we've got this equation, x and y. We've also got another equation in terms of x and y. Okay, and now that we got to this point, you should have alarm bells ring in your head. We can solve this simultaneously and get to our final answer. Okay, so this is a challenge part of the question. Okay, this is a difficult bit, getting to this point. The next bit, you're going to just watch me struggle through some simultaneous equations. Okay, so I'll tell you the final answer. So if you don't want to see me struggle through the whole part, actually no, I won't. You can watch me struggle, or you can just kind of skip ahead. So x squared plus, and then 5 minus 5/3 x squared equals 17 over 2. Okay, we just subbed in y into here, and let's go x squared plus 25 minus 25 x plus x plus 25 x squared 2. Fine. 34 over 9 x squared minus 50 plus 32. Okay, now thank God we've got our good calculators that can solve this for me. Okay, so we're gonna solve this polynomial, degree 2 polynomial, 34 over 9 minus 15, 25, that. Okay, so x1 equals 99 over 34, x2 equals 3 over 2. Okay, when you get nice x's like that, it's kind of hard to argue that you would be right. Okay, perfect. Now we need to figure out what our y's would then be. So using x1, we have 5 take away 5 over 3, lots of 99 over 34, which gives us our y1 equals 5 over 34, and then our y2 is going to equal 5 to 5 over 3, so 3 over 2, which equals 5 over 2. Okay, and that there is our final answer. Okay, and we can now either put it in I and J form as the question asked for. Okay, so B1, I guess, or vector B1 would be 99 over 34 I plus 5 over 34 J, and then B2 would be 3 over 2 I plus 5 over 2 J. And that now is our final